Welcome back. So I've picked some problems from section 5.4 of the Thomas's Calculus book that I wanted to do with you. Fundamental Theorem of Calculus Practice. I have starred here 14, 19, and 22. This podcast, we may only have time for one of them, but, the consecutive podcast will follow through. So let's see, I rewrote the problem here. And style-wise, there's lots of ways you could rewrite this integral. But you're going to notice one thing that I do, I think, from the start. And hopefully you're looking at that thinking, wow, it looks like she's doing separation of fractions. So just kind of rewriting the integral. You'll see it almost looks like, and I'll highlight this in another color, it almost looks like I went like this and then went like this. Right? So I just rewrote it as a half minus cos 2t over 2, okay, dt of course. Okay, now now you just kind of go piece by piece. What's the integral of a half? And so hopefully you're thinking a half t. This is with respect to t. And what is the integral? Here, the coefficient is a half, so I'm not really worried about that. In fact, I'll just write a half off here to the side. But I'm just going to zoom in on this. What's the integral of cos 2t? You may have to go off on the side and note to self, think about that for a moment. This means, what thing, if I take the derivative of it, will, get me to cos 2t? So I just kind of went off on the side. I always like to go off in the margin and sort of think about things. If I take 1/2 sine 2t and go and take the derivative of it, would it get me back to cos 2t? And if you think about it, the derivative of sine of 2t is cos 2t times 2. So then if you multiply that by a half, 2 times a half is 1. So that would indeed send you back to what you want. So okay then. So a half sine 2t. Okay, and of course we're going to bound that from negative pi thirds to pi thirds. Okay, now what you want to do is clean that up a little bit. So here, right, like a half times a half is a fourth. So I'll let you take a moment to clean that up. Okay then, so all I did was take this here and just kind of clean it up a little bit before I, evaluated the bounds. So I wrote that on the next slide. Okay. Now, let's go ahead and, I like to think of it as plug and chug. Let's take the upper bound, store it in. So, meaning store it in every place you see a t, right? So, a half times pi over 3 is pi over 6. Okay, then, and I'm just going to write it out, minus a fourth sine 2 pi over 3. And that's something we could think about of what that is. I'm just going to chunk that off. All of that minus, and now we're going to have to store that lower bound in, that negative pi over 3. Well, negative pi over 3 times a half is negative pi over 6. And then, of course, you've got minus a fourth sine of negative 2 pi thirds. Pen's being fussy there. I should say negative 2 pi thirds. All right. So now we just have to think about that and evaluate it. I'll hit pause as you do that. I did want to mention, if you're a little rusty with your trig, when you're thinking about sine of 2/3 pi, I mean, you clearly could type it into the calculator, but I don't think that gets you anywhere. Think about the unit circle, and think about the ordered pairs that live along the unit circle. So the coordinates in that first quadrant, 2 pi over 3 is the same as 60 degrees. So then if you think about the reference angle here, I'm sorry, pi over 3. Pi over 3 is the same as 60 degrees, and we can use that to help us figure out 2 pi over 3, what the coordinates would be. Well, clearly the coordinates would be -1/2 on the unit circle, comma √3 over 2. So some of you are very, very comfortable with trig, some of you aren't, but you can't just type it in the calculator unless you have a pretty fancy calculator, which many of you don't. So sine of 2 pi over 3 is going to take us to √3 over 2. And we want that times 1/4. Now that I've had you think about the unit circle a little bit, I'm going to go ahead and erase that. So pi over 6. We have that quantity. And now here, negative pi over 6 minus 1/4. And again, if you're thinking about sine of negative 2/3 pi, you're just rotating the other direction. Or you're rotating clockwise instead of counterclockwise. So we would have, you'd be at negative √3 over 2. So if I keep cleaning this here, -1/4 times negative √3 over 2, though it's going to be positive. So it's going to be positive √3 over 8. And here I have negative pi over 6. And I'm just going to keep that in brackets until we're ready for our final cleaning phase. Here we've got pi over 6 minus √3 over 8. And then I'll just highlight in another color here that we are going to distribute the negative. So be very careful there. So after you distribute this negative, negative times negative is a positive. So you have positive pi over 6, but you'll have negative √3 over 8, as we see here on this slide. Okay. Now we sort of pin together all the like terms, or combine the like terms. So pi over 6 plus pi over 6 is 2 pi over 6. And, negative √3 over 8 minus another √3 over 8 is a negative 2 √3 over 8. And if you get to there, that makes me happy. You just want to clean a little bit, reduce a little bit. So it goes into itself once, goes into that 3. So now you've got pi over 3 minus 2 goes into itself once, 2 goes into 8, 4. So you've got minus √3 over 4. And voila, that's your final phase. Notice your final answer is in decimals. When I see decimals, it indicates to me that somebody just typed things in their calculator and didn't use their unit circle, or isn't comfortable with trig. So, all right, hope that helps. I want to keep these podcasts pretty short and sweet, so I will do, let me show you. So this was our first problem, 14. In the next podcast, I'll hit 19 and possibly even 22, since those are a little easier. All right, good luck.